Welcome to EDU World Space.
So in this example, we have a situation like this. We have a non-uniformly charged sphere, something like this. Overall, it has plus 2q charge. And on the inside of it, there are some electrons at a distance d away. And we want to find what is this equilibrium distance. In terms of parameters like the radius of the atom. Okay. Well, I know from Gauss's law that if I have a non-uniformly charged sphere, that the electric field is the following. K, this is just a constant, 99, 9 times 10 to the 9th, times Q, the total charge, R, the distance that you're at, divided by R cubed. And this is the total radius of the atom. In order to solve for this distance in terms of the properties of the atom, we make use of the Newton's second law, which says that the sum of forces must equal 0. Okay, so here we go. I know that the force on this electron, we need to identify them. So the force on this green electron equals the following. K Q squared divided by 2 d squared. This is just Coulomb's law between two charged objects, the force between them. Q is simply the elementary charge E, so Q equals E, elementary charge. And this 2d is because the distance in between these electrons is 1, 2, d. Okay, so this is the force of the green electron due to the blue electron. All right, now what about the force on the electron, on the green electron, due to this non-uniformly charged sphere? Well, in order to figure that out, we have to remember that there can be a force on an object if it has some charge and it's in the presence of an electric field. So here we go. Force due to electron plus the force due to our non-uniformly charged sphere when we are a distance d away. Remember, the small r is the distance we're at. So here we go. Plus q times k q r. So here we go. We get another q. Times the distance d divided by r cubed, the total radius of the sphere. Remember, we need to have the sum of forces equal 0. So here we go. One other thing that's very important to note is that when we are talking about the total Q, it is the total charge. And so this Q right here must represent the total charge inside that we are speaking of. So maybe we should write it out more explicitly. We have K, E squared, elementary charge squared, divided by 2D squared, plus E times K, that's just a constant 99, over R cubed times D, and then we need to worry about this, which is actually 2E. Why? Because we have 2 electrons inside. 2E. All right. Let's set this equal to 0. We get negative factors. We see that the K's cancel. Remember that E is a negative number. So this right here, we can think of as being a negative. And we can think of this as being a positive. So that's why when we put it to the other side, the negatives cancel. Overall, we get the following. K, E squared. Excuse me, we already canceled the K. E squared over 4D squared equal to 2 E squared D over R cubed. Now solve for D, and we see that it equals R over 2. And that's the answer. A little bit confusing, but mainly just because we have to remember to include the right Q right here. After that, it's not too difficult. That and making sure that we understand that there is an extra negative that cancels out. And it all works out. There you go.